Okay, so completing the square. So it sounds like many of you remember doing this from Pre-Cal 20. If you don't remember this, we're going to go over it right now. Here's the thing. When we're talking about inverses, okay, so if you have something like this, and we go ahead and we switch or reverse, right, to find the inverse, we reverse the variables. In this case, where we have a straight line, degree 1, it's really easy to solve for y. We have y in one spot, right? So we go x minus 1 equals 3y. And then we go 1/3 x minus 1/3 equals y. And it's really easy to solve for y. The problem becomes when you have y in two spots and they're unlike terms, how do you solve for y? And that's where completing the square is going to come in. So when you don't have a case with a linear function, and you're going to have to complete the square. So it says here, determine the equation of the inverse of f of x by first rewriting the function in this form. So we have a standard form here, and we're going to try and get into vertex graphing form. So we're not going to flip the variables just yet. Not going to reverse them just yet. We're going to write f of x in this form. All right, so here's how we complete the square. Now, what we're trying to get, what is the square we're trying to get? Okay, well, the square we're trying to get is this part right here. We're trying to get this as part of, you know, the expression. Right now, we don't have anything in brackets. So we don't have a binomial squared. We want to get that. So how do we get that? Well, we can take a piece of this right here, and we can understand that this is actually a portion of a perfect square trinomial. Because in order to write a trinomial like this, it would have to be a perfect square trinomial, right? And so this is what we do. We literally make this a perfect square trinomial, and that's called completing the square. So this is what we do. It has to be a plus something here in order to complete the square. So this is, we're going to make this a perfect square trinomial. Now, I know what the issue is right here right away. You're thinking, how can I just add something to an equation? I can't just do that unless I do it to both sides. That's true. So if we add something to the right side, we could add the same thing to the left side. Or we could subtract the same value from the same side. That's the same. So this is literally what we're going to do. We're going to add the final piece of the completing the square, and we're going to subtract it off as well to maintain, to preserve the equality. Okay? All right? So how do we complete this square? This is going to have to turn into something squared. It's going to be an x, right? It's going to be either plus or minus something. Okay, so how do we figure that out? Well, if you think about perfect square trinomials, like let's just do this. Let's expand this. That's x plus 2 times x plus 2, right? And that's going to be x squared plus 4x plus 4. Okay, so x plus 2 is what I'm trying to get to from something that looks like x plus 4x plus 4. Well, guess what? How do I get 4 from this? It's not the same, and this is maybe a poor example. But what we do is we take half of this one, if you remember, and then we square it to get this value. Half of this term. So that means we're going to take half of this term, and we're going to square it to complete the square. So this is going to be what? Yeah, 16. Very good. Okay. So now this is a perfect square. We have to remember to preserve the equality by subtracting 16 to the same side. So if you add whatever you add by putting this number here, you have to subtract it off outside, or on the same side. So this becomes now x plus what? What's going to go here? Compared to this number, this is the half. This is what we squared, okay? Because 4 squared is 16. 4x plus 4x is 8x, you see? All right, so that's how you complete the square. And then over here, we combine these like terms. 12 minus 16 is minus 4. All right. So again, what you do is you take the half of what would be a trinomial, so this part right here, and we're going to complete it. And whether this is positive or negative, when you square it, it's always a positive. So a perfect square trinomial always has a positive here. That's why we automatically add it. So you take half of b and you square it. This b term. Half of it, square it. That's how you complete the square. Okay? Now what I've done is I've graphed these two. I've graphed both of these. This is a bit of a mess now. But I've graphed this original right here and this new one, the completed square. I've graphed them both on Desmos here. So you see, here's the parabola, x squared plus 8x plus 12. And here is, I think, this right here, right? That's what we just got. So I'm going to light this up, and look at that. It's the exact same as this one. Hard to tell maybe to see the color change, but it's right on top of each other. So that is the completed square, okay? That's the first part. Second thing we need to look at here now is to find the inverse, okay? So now we simply reverse, and of course, this f of x is the same as what? Y, okay? So now we reverse the variables, and we can solve for y, because y is going to be, I'll do it up here, y is going to be just in one spot now. Okay, so reverse the x and y, and solve for y. So now I need to get this all by itself, no problem. I'm going to add 4 to both sides. I'm going to get rid of the squared by taking the square root of both sides. Now, you have to remember, when you take the square root of something in the solving process, it actually is plus or minus, and we'll talk about this in a sec. And then this squared is gone with the root sign, so that's just y plus 4. And now y equals this, plus or minus the square root of x plus 4 minus 4. Or you could write it like this, negative 4. You could write that first if you want, plus or minus root x plus 4. Now the plus or minus, okay, I'm going to show you on the graphing why this is the inverse of the full parabola. Now you remember we've been learning that in order for the inverse to be a function, a lot of times we only take half of the parabola and then we reflect that, right, about the y equals x. So this is the full, and I'll show you the example here. So here we have the parabola, here we have the y equals x line, and look at down here. See, look at, if I light up just the plus, so the positive one, I get half of the inverse parabola. If I also graph the negative one, you see how that completes the parabola? It's like you graph it 2 functions. You graph 2 functions, and so that it's a function and a function, and it looks like now the full parabola. Okay? So normally we'll just maybe graph half of the parabola, and so that we would have one arm of the original and one arm, let's say, of the inverse. Okay? But anyways, so that's how that works, okay? Questions? Okay, so please take a moment and do B on your own. See if you understand now what you're doing. I'll just leave this up for a few seconds here. So go ahead and write the inverse for B by first completing the square. Okay, so that should be the completed square version there. Now let's reverse the variables, and we'll solve for y, okay? And it doesn't matter if the constant is in the front or behind, doesn't really matter. Okay? So did you get that? Does that look good? Did I make any mistakes up there? Did you guys get that? Yeah? Okay. All right, so completing the square, very important. You'll run into that here and there. And just a reminder how to do that. Okay.